Hello, my name is Jeremy,
And I'm Alec.
and today we'll be presenting on our final project in Deep Neural Networks course. So what our project is on the effects of absence and existence of Bandanhau attention mechanism in predicting stock prices of tech companies. So why do we do this? We do this because we believe in making smarter business decisions. Stocks are known to be a very volatile sector. Recently with COVID-19, we've seen that there are many factors that can contribute to the volatility of the stock market. Nonetheless, stocks are a huge part of the economy and our daily lives because it's important to make smart business decisions and investment decisions. And that is why we want to do this project. So due to the time series nature of our data, we will be working with recurrent neural networks, and specifically, we'll be working with long short-term memory layers, or otherwise known as LSTM, because it is known to mitigate the effects of exploding and vanishing gradient problems. On top of that, we will be exploring the effects of the existence and absence of Bandanhau attention mechanism, because we believe that the global nature of this attention mechanism will be able to pick out trends in the time series data and help improve the performance of the models. So let's talk about the data. Our data is from Kaggle, and it has stock market records for many companies. And the format is as such. It gives us the text file where the first row is identifiers for the columns of information below. And the following information are chronological by day, chronological records of stock prices for a given company. So the first is the date, second is the opening price. The next are highs and lows of the day, closing price, volume of the stock, and the open interval. So for data pre-processing, what we did is like this. So we have seen that the text file is formatted like this, but what we did was we removed the column. So we are just left with the opening price of each company stock. And we did this because we are using the opening price as a sole feature for our learning problem. And we are predicting the opening price and making our learning problem one of regression. So how we will do it is like this. So we will put in an input vector of n time steps of opening prices. And what we will be predicting is the opening price of the n+1th day. And we will be sliding this window down one by one and feeding this vector into our model. So we are eventually left with predicting the opening price of following various windows. So let's talk about the setup and comparison. First, we will identify the control architecture and the experiment architecture. And the main difference between these two architectures is that the control has no Bandanhau attention layer, while the experiment does. So what will be kept the same between these two architectures is that they will both use LSTM layers. They will both use the same set and initialization hyperparameters and same data preprocessing methods. But to emphasize on the set of hyperparameters, we will tune and optimize the set of hyperparameters with the control architecture on an arbitrary data set that we will set to be Microsoft. And in this case, Microsoft will be representing the stock market of prices of the other tech companies like here, Apple, Google, Facebook, Amazon. So to actually compare these two architectures, we will be creating a model that inherits the control architecture, which this model has no attention. And the other model will inherit from the experiment architecture with the Bandanhau attention layer. And we will be testing on these four companies and comparing the model's performance using the mean squared error metric.
Yeah, and so I'll go ahead and talk about kind of the more the experimental process that we went through. And the first thing we want to kind of put out there is a hypothesis. And we hypothesize that the Bandanhau attention layer will lower the MSE for the stock prediction and ultimately result in a better kind of set of predictions than the base LSTM model. And so the first thing we wanted to do was to get the best base model or control model that we could possibly get. And this is done through hyperparameter tuning. The first one we wanted to do was just the number of nodes within a layer. And we see that kind of in the model on the left that the lowest MSE given was 30. And here on the right is just a visualization of that. And so where the red line is the predicted stock price, and the green line is the given. And so we see that it's actually pretty accurate here. And the second thing we tried was changing the optimizer. So on the left is the atom optimizer, the right is the normal stochastic gradient descent. And we see that SGD, the atom optimizer, highly outperforms. The next thing we wanted to try was not necessarily something to do with the model itself, but more of a pre-processing step. And this is how the testing and training data was split. We kind of tried different ratios, so 90-10, 20, 80-20, and 70-30. And we see that with an MSE of 2.03, that the 70-30 split was the best. And so that's something we went with. Another thing we tried was varying the time steps. And so when Jeremy talked about splitting, giving an input vector n items, that n is talking about the time step. And so in this case, if your time step was 100, your input vector would be of size 100, considering the current day and the 99 previous days in your input vector. And then your output would be to predict the 101th day. And so in this case, we do see that 100 as a time step gives us the best MSE with 2.53. And so that's another value we want with. And the last thing we tuned was the number of hidden layers. We see that as the number of hidden layers increase, the test MSE increases as well, which is something we don't want. And kind of what we saw is as the number of layers increased, the training decreased. And so that's kind of an indication of overfitting here. And so we went with 2 as our number of hidden layers. And so the last part is more of the comparative analysis between companies, and so, or between the two models. So all the models on the left are without the Bandanhau attention layer, and all the models on the right are with the attention layer. And so we see that the Bandanhau, on the right is a lot more smooth compared to the rigidness of the the model on the right, on the left, sorry. And so the MSEs will be shown later, but just like an analysis, we see that the Bandanhau is a lot smoother on this one as well, and for Google and for Facebook. And something to note with Google and Facebook is that their data sets are actually a lot smaller than Microsoft, Apple, and Amazon, because I know Facebook IPO'd in 2012 and Google IPO'd a little earlier than that. And so kind of their data sets are a little smaller, are a little harder to kind of conceptualize for models and to predict. And so kind of the last thing here is just like analysis of what the model's actually shown. And so for Apple, the MSE without the attention was 25 and with was 39, so on and so forth. And we see that continue like over and over again, the MSE without the attention is lower than with the attention. And so this kind of rejects our hypothesis that the Bandanhau layer would help. And obviously there can be more like tuning and different like cross-validation techniques used to kind of reinforce this idea. But this is the conclusion we came up with. And so thank you so much for your time.
Thank you so much.